Okay, so we are going to start on the fifth section and final section of Chapter 3, and it is going to be exploring the focus in Directrix. We're going to have one learning target. It's that you're going to be able to write equations when you're just given a minimal amount of information, such as the focus and the Directrix. Okay, and so you're probably wondering, what is the focus in the Directrix? Well, the focus is a very particular point, and the Directrix is a very particular line that give a new definition to a parabola. So let's go ahead and see what that is. A parabola can be defined as the set of all points x and y in a plane that are equidistant, meaning the same distance, from a fixed point called the focus and a line called the directrix. So what does that mean? That means if I pick some random point P on my parabola, there is another point called F, the focus, and another point D, the directrix, which will kind of move along this line. The directrix is this line. Okay, so what this is saying is if I pick any random point on my parabola, the distance from my point P to the focus, F, P to F, is going to be equal to my distance from P to the directrix, D. So any point I pick, P, the point, is going to be the same distance from F as it is from this line called the directrix. So what I have done here is I have created a little visual for us to go ahead and see how this looks. So here V is my vertex. We should already be familiar with the vertex of a parabola. Here F is my focus. This blue line is my directrix. Now as I move my random point P, as you can see, the distance from P to the focus, PF, is 1.206. And my distance from P to D, or my random point to the D, the directrix, is 1.206. Okay, and this is going to be consistent wherever I put P. Okay, so wherever I'm putting P, these are going to always have the same value. Okay, so that is what the focus and the directrix is, and that's how they relate to our parabolas. Okay. We will be using the distance formula when we do these problems. So let's go ahead and practice that. Okay, so the distance formula, which you will need to know, is this. It is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. This does come from the Pythagorean theorem. That's why it looks fairly similar to it. Its root is the Pythagorean theorem, literally, but we will just be using the distance formula. I'm not really here to teach the distance formula more than what we're going to have right in front of us. Okay, so what we need to do is we need to find our x values and plug them in, and our y values. Okay, so let's label this point x1 and y1, and this one x2 and this one y2. Okay, and so we can just go ahead and plug these in and solve. So x2 is -3. Minus, because that's what the formula calls for, and then x1, which is -6. So whenever we have minus and -6, we should put a little extra parentheses there. Okay, and then we have y2, which is 2. And then we're going to subtract, again, -2, so I'm going to put a little extra parentheses there. Okay, and this one's good that we're minusing negatives so often, because this is a common mistake. We need to remember that subtracting a negative is addition. So this is going to be -3 plus 6. And this is going to be 2 plus 2. Okay, so -3 minus -6 is -3 plus 6. 2 minus -2 is 2 plus 2. Okay, and so then we can go ahead and say that this is 3 squared. -3 and 6 is +3. 2 and 2 is 4. Okay, so now I just need to know what 3 squared is, which is 9. And 16, which is 4 squared. And then lastly, I have to take 9 plus 16 is 25. And then the square root of 25 here is 5. So the distance between these 2 points on the coordinate plane is 5, which I have a visual here of that somewhere. Okay, so that would just be like if I had these 2 points here. Their distances here from here to here is 5 based on the x-axis difference being 3. The difference in the y values is 4. Pythagorean theorem tells me this is 5. Okay, so now that you have tried one, or now that we've done one together, why don't you pause the video and go ahead and try letter A on your own. Okay, so now that you have tried this one, here is the work. So x1 or x2, 4, minus negative 8, x1 squared plus y2, 6, minus y1, 1. Okay, and then 4 minus negative 8 is 12. 6 minus 1 is 5. 12 squared is 144. 5 squared is 25. 144 and 25 is 169, and the square root of that is 13. Okay. All right, and then when we do these problems, there will be one other little bit of information that's going to be reviewed that you will need to know how to do, and that is the FOIL method, or for us, which will be the box method. Okay, and we need to remember how to multiply these out, how to expand this essentially. So for us, in my class, you're going to see the box method a lot. I've picked it up within the last few years, and I really prefer this method over the others. If you have another way of doing this, feel free to do it. I'm okay with it as long as it's correct. Okay, so here what I like to do is I like to set up a box whenever I'm squaring a binomial. Okay, and the reason why I set this up like this is because x minus 4 squared is the same as x minus 4 times x minus 4. So I'm multiplying them by each other. So what I can do is I can set up a little box, and I can set up an x minus 4 here, and then an x minus 4 here as well. So you should have seen this in Algebra 1, and then maybe even a little bit into geometry as well. So x times x is x squared. X times negative 4 is negative 4x. X times negative 4 is negative 4x. Negative 4 and negative 4 is 16. Okay, and then these here, so this right here is my result if I multiply x minus 4 times x minus 4. But here we have some like terms that can be combined together. So what would this combine into? This would combine into x squared. Well, what is negative 4x and negative 4x together? It'd be negative 8x, and then plus 16. So x minus 4 squared is the same exact thing as x squared minus 8x plus 16. So this is review, and again, this is just going to be embedded in part of the problems that we're doing today, and it will just be a minor point, so I don't want to have that being a big sticking point, so I want to get practice with these now. Okay, so why don't you all go ahead and pause the video and try B on your own. Okay, so as I'm looking at this, I set up the box the same. It's x plus 5 times x plus 5. That's the same as x plus 5 squared. So x times x is x squared. 5 times x is 5x. X times 5 is 5x. 5 times 5 is 25. Okay, and then so this is all equal to x squared. 5x and 5x together is 10x, and then plus 25. Okay, so let's actually get into the stuff that you're going to need to be able to do for today, the specifics, and let's do this. So one thing that is important to note, if I go ahead and bring up this diagram I have here on the computer, as I have my parabola, they are all the same, but one thing that's really important to notice is that if you look at the distance from the vertex to the focus and the vertex to the directrix, that distance is going to be the same, just like any other point would be. Okay, and so this is going to be pretty important. So that distance between the vertex and the focus is going to be, I think we're going to call it like lowercase p. That will represent the distance here. Okay, so let's just go ahead and notice that the vertex is always directly in between the focus and the directrix. Okay, now one thing that is important to know is that our focus always is inside the curve. So if the curve is opening downward like this, it's going to be underneath and the directrix will be above. Okay, so this focus is always inside of the curve. So if it was facing downward, our focus would be down here and our directrix would be up here. Okay, so like the key to these problems are, in my opinion, being able to draw the diagram and what's going on. So hopefully you paid attention to what I was just laying out to you throughout the last few minutes, because they're crucially important, because writing the equation isn't super intuitive unless you kind of have the diagram there. So here I have a focus here. I'm going to use the distance formula to write an equation of a parabola with a focus and directrix given to us. So I have a focus at 0, 2. Okay, and then I have a directrix. Okay, and in this situation, it's going to be below my line or below my focus. How come I know this? What allows me to know that the directrix, my line y equals -2, is below the ordered pair or the focus 0, 2? Well, it's the y values. If you look at the y values here, this has a +2. This is -2. Well, these are -2 is clearly less than 2, so it's going to be below it. Okay, so what about the vertex? Well, I know the vertex is going to be right under the focus, and it's going to be exactly halfway in between. So let's think about what the ordered pair is going to be. Well, if it's exactly below the focus, that means that I'm going to have an axis of symmetry that will go through the focus and the vertex, meaning that I have an axis of symmetry of x is equal to what? What's my x value here if they are going to share the same x value because they're straight up and down? Well, 0, because my x value is 0 here. Okay, so there's the x value of the vertex then. It's going to be 0. And then what would the y value be? And again, the y value has to be the number that's going to allow this point to be exactly between this point and this line. Okay, so what's the number between the y value of 2 and the y value of -2? 0. Okay, and then again, I know that this opens upwards because the graph always opens towards the focus. Okay, we're almost done with drawing. And so let's pick a random point P. The thing about our random point P is that we don't know what the x value or the y value is. Okay, so we're just going to have to call it x and y. We have no other choice. We just don't know, because it can be any point, so it can be any xy point. Okay, the thing about P and D, they have one thing in common. They're going to be straight up and down from each other, very perpendicular to that directrix. So when I have my point D here, I kind of know some information about its ordered pair. I know that this x value here is going to be the same as this x value here, for the same reason f and v have the same x value. So since I don't know what P's x value is, I know it's just x, we're going to keep it as x. They'll have the same x value. But the y value is different. This point D is going to shift along this line just like my applet did. And the y value is going to stay the same. What's it going to stay at? -2. Okay? And this is the diagram. You're going to need to be able to draw this diagram. Okay? If you think it out, you just have to reason through thinking about your x values and your y values and how the coordinate graph works. Positive numbers for y values are up, negative y values are for down. So if you have a y value that's greater than another, it's going to be above it. Okay? So how are we going to use this? Well, we know that P to F, the distance of P to F, let's represent that. The distance from P to F is, if I use the distance formula, I know that it's going to be x2. Well, let's just call this x2 here. So x minus x1. So this would be x1 then, which would be 0. Squared, and then I'm going to add to it y2, which would just be y, minus 2. Okay. So this expression right here represents my P to F. And I know that P to F is going to be the same as my distance from P to D. So we can do the same thing with P and D. x2, x minus x1 also happens to be x. plus y1, y, or y2, y2 minus y1. So minus negative 2 is going to be plus 2. Okay, I'm going to start making little shortcuts like that because it's going to make our work a lot faster if we don't have to simplify literally everything. Okay, so now our goal here is just get the y by itself. That's how we're going to write our equation. It's going to be y equals something. Okay, now let's simplify here. X minus 0 is just x. Y minus 2 cannot be simplified. X minus x. Well, x minus x is 0. 0 squared is just 0. So that just is gone. We don't need it at all because 0 squared is 0. 0 plus whatever this is just going to be whatever this is. So there's no reason to keep it. So we're going to have y plus 2 squared. Okay, the next thing we need to think about is how do I cancel out these square root symbols? Because so far this year we have yet to solve anything that involves square roots. So I'm going to say this once. I'm going to say it again. There's going to be a whole chapter where I'm going to say it a whole bunch. Square rooting and squaring, they undo each other. They're inverse operations. So if I want to undo square rooting, I have to square each side. So I have to square each side. And the thing that's nice about this in equations is when I square and square root, they just undo each other. So they're just gone. All right. So then next, the thing is I would need to expand this. The same way we did just above where we reviewed the FOIL method. We did the box method though. So we just have to expand this out. So I actually already have those answers. For the sake of time, this is going to be x squared plus y squared minus 4y plus 4. And this is equal to y squared plus 4y plus 4. Okay, I'll show the work for me doing the box method on this very briefly, just so you know where it came from. That's me doing the box method on y minus 2 squared. That's me doing the box method on y plus 2 squared. Now again, this is kind of expected to know, this is 100% review, so I really don't want to spend a ton of time going over where this came from because we have other more pressing things to get to. Okay. So next, all I have to do is get the y's by itself. But before we do that, let's look at our equation. Our equation written here, we have a positive y squared and a positive y squared here. So if I wanted to get rid of this y squared, I would subtract y squared. And if I subtracted y squared here, it would cancel out on both sides. So actually here, these are just gone. Same with some other value, 4. If I subtracted 4 from each side, they would also just be gone. Okay, so what am I left with? I'm left with x squared minus 4y is equal to 4y. Well, I need to get all y's on the same side of the equal sign. So instead of minusing 4y here, I'm going to add 4y. So now I get x squared is equal to 8y. Then I need to divide by 8 to get y is equal to, my ideal answer would be 1/8 x squared or x squared over 8. These are the exact same thing. Okay, so really it's just some algebra after you get started. Okay, so what does this mean? This means that my parabola y equals 1/8 x squared is the specific and only parabola that has a focus of 0, 2 and a directrix of y equals -2. And that any point on this parabola will be the same distance from this line as it is to this point. Okay, so also getting 1/8 is a great sign for us because since that 1/8 is positive, that means the a value is positive, meaning that it's going to open up, which by our sketch, our parabola did. Okay, so the next thing I would like to do is I'm going to go oversee, and normally I would have you pause the video, which if you're feeling good after what I just did, feel free to pause the video. But on this one here, I'm going to go over it also because these ones are kind of hard to set up. At first glance, you're going to need some practice with it, maybe some extra reps. Okay, so here we have a focus of 0, -3. And this one, my directrix is y is equal to +3. So again, I want you to think about, how do I know that the directrix in this situation is above the focus? Well, I know it's above the focus because my y values here are -3 and +3. 3 is greater than -3, so it's going to be above. Okay. So my vertex and my focus are going to be on the same axis of symmetry, which is going to be x is equal to 0 in this situation because this has an x value of 0. So if that's the case, my vertex has the ordered pair 0 because they're all going to have the same x value. What's the y value going to be? Okay, how did I get the y value before? I looked for the y value that was exactly between 2 and -2. So here I'm looking for the y value exactly in between 3 and -3. Okay, this one also happens to be 0. You will see ones where it's not always at 0, 0 for the vertex. Just not in these specific examples. Okay, so now I have to find my random point P. Let's say it's here. P is always going to be xy. Okay, so as I find my point D, the x value is going to be the same as my P value. So this is going to be the ordered pair x, comma, and then what's the y value? Y value is 3. And then to here. All right. So let's go ahead and write the distance for P to F. Okay, so P to F is going to be the square root of x minus 0 plus, and then the y values, y minus -3, that's y plus 3. Okay, and now I have to do P to D. So this is going to be the square root of x minus x, okay, plus y minus 3. Okay, let's simplify. Well, this is gone. We don't need this anymore. X minus 0 is just x. And since that gone, that is just y minus 3. Okay, sweet. We're almost there, folks. Okay, lastly, we need to undo our square root symbols. How do I undo square root symbols? What undo square rooting? It is squaring. So square root and squaring undo each other. So I am left with x plus y plus 3 squared plus y minus 3 squared. Okay, we're going to have to do the box method for y plus 3 and y minus 3. This is an equal sign. So I have x squared plus y squared plus 6y plus 9. And then y squared minus 6y plus 9. Okay. And again, I would have got those doing the box method. I have methods to do this in my head, so that's what I did real quick. But boy, I promise you, if you use the box method, you will, of y plus 3 and y minus 3 squareds, you will get this. Okay, so let's look. What's going to cancel? Well, my y squareds are going to cancel. My 9s are going to cancel. So what am I left over with? I'm left over with x squared plus 6y is equal to negative 6y. Here, I'll subtract 6y. Get x squared is equal to negative 12y, then divide by negative 12. So here I'm going to get y is equal to negative 1/12 x squared, and then that is my answer. Negative 1/12 is going to open up pretty wide because this is pretty close to 0. And then also it's opening down because the y value, or the a value of our parabola, is negative 1/12, so that means it's going to open downwards, which is exactly what our diagram indicated. So that's a pretty good sign. Okay, great. great. Okay, so drawing the image is just such a big deal. I really can't stress enough how important I believe that to be. So focus on that. The algebra will come because most of the algebra is not new at all. Okay, so let's go ahead and put this back here. All right, so now let's go ahead and do one where in this particular situation, our focus and our directrix, our vertex, is not going to be at 0, 0. So in our previous two examples, our vertex ended up being at 0, 0. I picked those because those were easy ones to get started with. Okay, so now the majority of the ones we're going to be dealing with, the vertex is just not going to be at 0, 0. So the strategy is the exact same. Draw it out, use the distance formula. So let's draw these out. Here I have a focus at -4, 4, -6. Okay, so 4, -6. Let's put this right here. A focus of 4, -6. And then my directrix is actually above it at y equals -2. How do I know this? Well, -6 is less than -2, so it's going to be below. Okay, so now I have to draw my axis of symmetry here. My axis of symmetry is going to be x is equal to what? Okay, in the previous ones it was 0 because that was the x value. What's my x value here? My x value for this particular one is 4. So this is going to be x is equal to 4. Okay, and so then my vertex here, v, is going to be the ordered pair. Well, what's the x value? Hopefully you're telling yourself it's 4, right? Because I'm on this axis of symmetry with the x value of 4. And then y value of what? So again, we're looking for the number exactly in between -6 and -2. So you just want to average these two numbers, okay? So what's the average between these two numbers? Well, it would be -6 plus -2 divided by 2, which is -4. -4 is the number directly in between those two numbers. So -6 plus -2 divided by 2 is -4. So for this one, my vertex is at 4, -4. Okay, my parabola is going to open downward. Okay, it's going to open downward because the focus is downward, so it's going to open downward also. Okay. My point is still xy. My point D is going to be x, comma, right? It's always just going to share x. But the y value here will be -2. All right. There's our diagram. We're ready to go. Let's roll. Okay, so my distance from P to F. Again, the only difference in these problems is my vertex is not 0, 0. This one is 4, -4. Okay, so here, P to F. So we're going to have the square root of x minus 4 squared plus y plus 6 squared. Okay, I know it's plus 6 because y minus -6 is y plus 6. So this is P to F. Okay, P to D. Okay, this is going to be x minus x again. This will basically happen every single time, folks. And then y minus -2 is y plus 2. So here I have the square root of, well, x plus minus 4 can't simplify. Okay, x minus x is 0, so this is going to go away. And then I have y plus 2 squared and then the square root of that. Okay, so let's go ahead and square each side. Okay, when I square each side, the square root symbol is going to go away. So now I'm just left with x minus 4 squared plus y plus 6 squared is equal to y plus 2 squared. Okay. Now, the only big difference about these problems is if you look here in the previous one, this is just x squared. Well, for our problems, actually, you don't even have to expand that x minus 4. This can stay exactly as is because when we're done, you're actually going to see it. It's going to be pretty cool. it's going to simplify down, and it's going to be an exactly vertex form, the first form we dealt with in this chapter. Okay, so let's expand this. Again, use the box method to expand this and this. Okay, this is x minus 4 squared. This is going to be y squared plus 12y plus 36. And this is going to be y squared plus 2y plus 4y plus 4. Okay, if you look here, our y values cancel out still. But unfortunately, these values do not. Okay, so that's another difference here. So we're going to have x minus 4 squared plus 12y plus 36 is equal to 4y plus 4. Okay, so now I want to move my y's to this side and everything else to the other side. So we're going to subtract 12y to get x minus 4 squared plus 36 is equal to, this is negative 8y plus 4. Okay, and then now I need to get rid of this plus 4 by subtracting it off to the other side. So now I have x minus 4 squared plus 32 is equal to negative 8y. And now I just have to get the y by itself, which is going to be done by dividing by negative 8. And so I'm going to have negative 1/8 x minus 4 squared. Okay, and so then this negative 1/8 is me dividing this by negative 8. And then I have to divide this by negative 8 also, so be very careful about that. 32 divided by negative 8 is negative 4. Okay, so y is equal to negative 1/8 x minus 4 squared minus 4. So this parabola has an, if you look at this, this is vertex form, has a vertex at 4, negative 4. It's going to open downward and it's going to open up pretty wide, which is kind of exactly what we have here, which is great. Okay. All right, so now that you've seen a couple of the diagrams drawn, I think now is a good time for you all to try this one just on your own. Okay, you're probably, there's a good chance you're going to make some mistakes. It is what it is. A mistake is a mistake, especially on notes. Go ahead, and the important thing is if you do make a mistake, try to figure out where it's at. Okay, so I'm going to pause the video right now, and I'm going to let you all work on that, and then start it back up when you are done. Okay, so as I am going through this, I drew our diagram here, right? Vertex is going to be negative 2, because they're going to share the same x value at negative 2 here. And then the y value, this is the number exactly in between 3 and negative 5. P is still xy. Directrix point, the D point for us is going to be x and then comma negative 5, which I actually screwed this up the first time, so it's a little sloppy. It's still good. You should hopefully be able to see everything. Okay, so here is P to F. Okay, P to F is going to be x plus 2 squared plus y minus 3 squared. And then P to D is going to be x minus x squared and then y plus 5 squared. Okay, I square each side after I simplify to get rid of the square root symbols, and I'm left with this. Okay, and then I got y minus 3 squared is y squared minus 6y plus 9 using the box method. And then y plus 5 squared is y squared plus 10y plus 25, again using the box method. After that, my y squareds cancel out, and then I want to start moving all the y's to the opposite side. So I add 6y to each side to get 16y. Okay, and then after I did that, I subtracted 25 here to get negative 16. Divide by 16 to get the equation 1/16 x plus 2 squared minus y, 1 is equal to y. Okay, so I'll just kind of leave this here for a moment so you kind of see it. Pause it if you need to. Okay, honestly, folks, those are the harder problems. We've already cleared the hardest stuff from here on out. It is just going to be us dealing with some formulas. Okay, So what we want to think about is just like the standard equation of a parabola. When you're given the focus and directrix, actually has some pretty major shortcuts. So really the equation is going to be 1/4, but 1 times 4p x squared. Okay, and so then this is going to be when our vertex is 0, 0. V is 0, 0. Okay, whether it's opening up or down. Okay. And then here we're going to have some directrix line. Okay, and the focus is going to be 0, comma p. Okay, and the directrix is going to be y is equal to the opposite of p. Now let's talk about what p is. Okay, p, so here's my focus, which is 0, comma p. That's my focus. Okay, so what is p? P is going to be this distance right here. Okay, this is my little lowercase p here. That is going to be the distance in between what do you call it? It's going to be the distance in between the focus and the vertex. Okay, so this lowercase p here is going to be this distance here in between. Okay, so given this information, we'll start to decipher where this all is coming from and how we'll get these numbers, because actually you don't need the focus and the directrix. You can have the focus and the vertex, and that will give you enough information as well to write the equation. So that means that the directrix will be y is equal to the opposite of that p-value. Okay, now this here is going to work when the parabola is opening up. Okay, this is going to be when the parabola is opening up. What about when it's opening down? When it's opening down, it will be a little bit different. Okay, so I just did, yeah, this is fine. Okay, so I'll do up in black, and then I will do down in red. Okay, if it's opening downward, okay, it's mostly all going to be the same. It's still going to be y is equal to 1/4 p x squared. But this is going to be negative now. My focus is now going to be 0, comma negative p. And then the directrix will be y is equal to just what that p value is. Okay. So let's go ahead and try some of these problems out. Oh, sorry. All right. So this is p, and then this would be 0, comma negative p. Okay. Sweet. Okay. So let's go ahead and look at this. So here, I'm going to write the equation of a parabola with vertex at 0, 0. Okay, so the vertex is 0, 0. Okay, and so basically, I just need to figure out our distance, right? And the thing that's nice is, even though I mentioned up here that lowercase p is the distance from the vertex to the focus, it's also the distance here, since they're the same distance. It's also going to be the distance from the directrix to the vertex as well. Okay, so let's go ahead and think about what our p-value is here. Okay, so our p-value is what? Okay, so how far is 0, 0 from this line? Well, we could go ahead and really just sketch the bare minimum needed, right? Okay, there's 0, 0. Here's y is equal to -4. So then I want to know, what's this distance right here? To get from -4, y value of -4 to 0. Well, this is a distance of 4. So our lowercase p is 4. Okay, so what is this p is for? So now all I have to identify is whether this parabola will open up or down. Well, knowing where the vertex is at and the directrix is below it, that means the focus is up and it's going to open upwards. Okay, so this is going to be a parabola that's going to open upwards. So what's the equation? This is going to just be y is equal to 1 over 4 times my p-value. Well, my p-value is 4. X squared. So this is going to be y is equal to 1/16 x squared. Okay, and all I did was just, use this chart right up here. Okay, what about if I have the focus? The focus on this 6 is 0, -3. So here, okay, and again, we know the vertex is 0, 0. So here I have the focus, which is 0, -3, and the vertex, which is 0, 0. Right, so 0, this would be below because this y value is less, right? So this is going to open downward. Okay, so we know this is going to open downward. Okay, and so I just have to figure out what this p-value is. How far is -3 from 0? Well, it's 3 units away, correct? So since it's 3 units away, okay, the only difference is I have to use a different formula because it's opening downward. Okay, so it's y is equal to 1 over -4px squared. Okay, so this is going to be y is equal to 1 over -4 times, this one would be 3, x squared. So this means it's y is equal to -1/12 x squared. Okay. Basically, you just have to figure out, is it going to open up, is it going to open down, and how far is that point away from the vertex, and plug in the numbers. Okay, so I'm going to let you all try the next two on your own. Check it with me when you're done. Okay, so on E, I'm looking at this, and I know that the focus is above the vertex because my y value is greater than, and it's 5 units away from it. So I replace P with 5, okay? And so I have y is equal to 1 over 4 times 5 x squared. 4 times 5 is 20, so it's 1/20 x squared. Okay, here, similar to the directrix, so I have the line this time, and the directrix is above the line because 2 is greater than 0, and so that means that it's going to open downward. Okay, I know that the distance between these two values are between this point and this line here is going to be 2. Okay, so y is equal to 1 over -4 times 2 x squared, and that will be -1/8 x squared. Okay, all right. Hopefully I can write a little neater on the next one. That was not my best work, I believe. Okay, so, okay, what about if the it's at a random point hk? Well, so if I have some random point hk, and that's my vertex, and let's say this one's opening upward. Okay, and so that means I would have a directrix below it and a focus above it. Okay, the focus is going to have the same h value as the vertex does. Okay, and so now we have to think about what is the y values of the directrix if I have, what's the y value of the directrix and the focus if I have this. Okay, so you need to think about, again, what's this p value, this little lowercase p value that is the distance, from the focus to the vertex. Okay, and so this is going to be quite helpful because it's going to be, if you think about this, if this point here has a y value of k, and this here's length p, this is going to have the y value of k plus p. Because from on the y-axis here, if this is k, and then this red length is p, this length is going to be k plus p. Okay. And so then here, again, if this is k and this length is p, this y value is going to be k minus p. Okay, so let's go ahead and look at the equation. All right, and so then here my equation, Again, I'll try to do up. When it's opening up, is going to be y is equal to 1/4 p times x minus h squared plus k. This is in that vertex form that we've dealt with in the past. Okay, the focus, again, is going to be h and then k plus p. And then the directrix will be y is equal to k minus p. Okay, and then quite the opposite of that, right, for when we're going down. So I'll do down in red. This one's a little better. Okay, so here, what if I have a vertex here at hk? This is my vertex. Okay, that means the directrix is above it and the focus is below it. Okay, so in this one here, again, this distance here is p. This little distance here in red is p. So that means if this has a value of k, this here would have a value of k minus p, right? It's this k value if you took away what p is. Okay, and then here, my y value would be k plus p. So this focus would be h and then k plus p. Because right here, right, if this is k, if I'm lowering this distance by p, it's going to be k minus p. I think I put plus, but this is minus. Okay, so basically everything's the same. The only difference is the equation will be y or negative 4p, and then everything else is the same. Okay, so that p value is the only thing that really messes it up, is like when do you add and when do you subtract. Okay, they're just inverses, right? So if it's opening up, you're going to add p to the focus and subtract p from the directrix, and the opposite of that if it's opening down. Okay, again, let's just do some problems here and see how you do. All right, so as I am working through 7, again, it never hurts to have just the bare minimum sketch. It just helps you understand and give you a visual so much better. Okay, so here I have a vertex at negative 1, 4, and that will be the vertex, so that's right here. Okay, and so then here I have a focus at negative 1, 2. Okay, if I look at the y values, this is actually below it. Okay, so here's my focus. Negative 1, 2. Okay, so that indicates to me that I'm opening downward. Okay, so here it looks like to me we have to just identify 3 variables, right? We just have to identify p, h, and k. The nice thing is that h and k is the vertex. So I already know that h is equal to negative 1, k is equal to 4. I just have to find that sneaky p value. Once I do that, I will get everything else I need. So I just have to find this distance. What's the distance between my vertex and my focus? Well, if this is at negative 1, 4, and this is at negative 1, 2, that means this distance here is just a distance of 2, meaning my p value is just 2. Okay, it's opening down, so I'm going to use the down formula. All right, so that means I'm going to get y is equal to 1 over negative 4 times 2. And then that times x minus negative 1. And then plus 4. Okay, just using the general formula that we used above. P, H, K. Okay, and so then here our final answer is going to be y is equal to negative 1/8 x plus 1 plus 4. This right here is my final answer. How did I get the 8? Well, negative 4 times 2 is negative 8. Minus negative 1 is plus 1. And then obviously that 4 is there just to stay constant. Okay, let's do 8. So 8, I have, this one I have the directrix. Okay, so let's draw the directrix here. It's y equals to 3. And then here I have a vertex of 2, 5. Okay, so that means my h value is 2, my k value is 5. I just need that p value. So I just want to figure out what this distance is right here. Okay, that distance there would be, well, if this is y value 5, this is y value of 3, this has a distance of 2. Okay, and so then I can start the formula. Y is equal to 1 over, well, let's just think. This one would open upward, right? Because the directrix is below it. Okay, so this would just be 4 times 2. And then times x minus 2 squared plus 5. Meaning that the final equation is y is equal to 1/8 x minus 2 squared plus 5. And again, that's in our vertex form that we dealt with at the very beginning of the chapter, so that's pretty good. Okay, I'm going to pause the video now, and I would like you to try G and H on your own. Okay, so here I have my directrix at y equals -2, which is above my vertex of -5. So I'm going to use the opening downward one. Okay, so it's going to open downward. H and K are 3 and -5, and they have a distance of 3 between them. So I plug in my p value 3, my h value 3, my k value -5. Simplify, and that is my answer. Y equals -1/12 x minus 3 squared minus 5. Okay, and then last here is we have a vertex of 5, 8 and a focus of 5, 12. Okay, the focus is above it, so I know that I'm going to open upward. They have a distance of 5, making h5 or a 4 between them. So I have h is 5, k is 8, and p is 4. Plugging in, p is 4, h is 5, k is 8. I simplify to get y equals 1/16 x minus 5 squared plus 8. Okay, so where are we going to see this? Okay, so we can see this in certain satellite dishes. Okay, so an electricity generating dish uses a parabolic reflector to concentrate its sunlight onto a high frequency engine located at the focus of the reflector right here. So that means this engine here is my focus. Okay, the sunlight heats the helium to 690 degrees Celsius to power the engine. Write an equation that represents the cross section of the dish shown with its vertex at 0, 0. So we have this vertex at 0, 0 here, and basically what it wants to know is it wants to know like what's this cross section, this part I'm like dashing in. It wants to know like what's kind of the path this would be taking to kind of give us like a width of like how wide should this be. Okay, so what's the information we're given? Well, we're given the focus, right? Because if the vertex is at 0, 0, the bottom of this, the focus would be then at 0, comma, based on our diagram, what's this y value? If they're 4.5 apart, what's 4.5? Okay, so what does that allow us to do? Well, it allows us, if you go back to our previous page, which I just put away, previous 2 pages. This is a parabola that's going to open upward, and the focus is at 0, 4.5. We just have to find this distance here, and then all of a sudden we have the equation. Well, what is this distance? Okay, so based on this diagram, this has a distance of 4.5. Okay, it has a distance of 4.5. And then the equation is just simply y is equal to 1 over 4p x squared, where p is that distance. So this means this is going to be y is equal to 1 over 4 times 4.5 x squared. And I do not know what 4 times 4.5 is. So 18. Actually, I probably should have known that, but that's all right. So the outline of this bottom part of my cross section, if this is the middle, our parabola is going to go y is equal to 1/18 x squared. Okay, and then that will help us. Okay, if I wanted to know the depth of the dish, which is the last part, what's the depth of the dish? So this allows me to get this like outer bottom part. Okay, if I want to know the depth of the dish, that means I want to know what's this distance to this distance right here. Okay, so we need to think about, if this is 8.5 feet here, what's the distance from here to here? Like, what's half of this? What's this distance? Okay, so 8.5 divided by 2 is 4.5, or 2.5. So that means then this distance is 4.25. So the y value here, this y value here is going to be the depth of this dish, right? It's the depth of this dish if I plug in when x is 4.5, right? Because if I go out here, x is 1, x is 2, x is 3, x is 4.5, that's the edge of here, and then it will give me the y value that coordinates with it. So we're going to pick x is equal to 4.25, and we are going to plug it in. Y is equal to 1/18 times 4.25 squared. And I'm just going to use the calculator for that. So this is going to be 1/18 times 4.25 squared. So about 1.003. So it's about 1. It's going to be about 1 meter based on our units here. So the depth of this dish is going to be about 1 meter altogether. Okay. So a parabolic antenna is 16 feet in diameter. So here I have a diameter. This whole thing is 16 feet. Okay. And we want to write an equation that represents the cross section of the antenna with its vertex at 0, 0 and its focus 10 feet above it. This would be 0, 10 then. Okay, so if we can imagine just a satellite like this, give or take. Okay, so we just want to know what's this middle distance here. What's this distance here? It's 10. Okay, and so then we can use the equation. Y is equal to 1/4 times 10 x squared, which means this is y is equal to 1/40 x squared. So this is going to give me the tracking of, it's going to tell me how high up this is going to be at any point on the dish. Okay, using the x, but I want to know the depth. So again, the depth is going to be this distance here to this distance here. This is my depth. Okay, and I got to figure out what x value is going to correlate with this, right? So again, if this whole thing's 16 and this is 0, 0, this is the value x is equal to 8. Okay, so if this is x is equal to 8, we can just plug that in. Okay, so then here we can go ahead and do the same thing. So this is going to be 1/40 times 8 squared, which is 1.6. So this thing has a depth of only 1.6 feet. Okay. All right, folks, that's the section. It's a little bit of a longer one, and I apologize for that, but that's just kind of the way she goes sometimes. Otherwise, I think it's a good time just to move on to your homework and then the review for this section. I will see you next time.